All right, Unit 2, Lesson 3, Congruent Triangles, Part 1. So our learning goal is let's use transformations to be sure that two triangles are congruent. So what does it mean to be congruent? So looking at the warm-up 3.1, true or sometimes true triangles. So if triangle ABC is congruent to triangle A prime, B prime, C prime, what must be true? So what does it mean to be congruent? In this example, you have two different figures entirely, right? Two different triangles, but they're told to be congruent. So what does that mean in terms of, let's talk about the angles, right? Let's say for the angles, the angle, let's say CAB, all right, needs to be congruent to the other corresponding angle, which is C prime, A prime, B prime, right? So these corresponding angles need to be congruent to one another. We also know that the angle ABC needs to be congruent. And here's angle ABC, and it needs to be congruent to A prime, B prime, C prime. And then lastly, the other pair of angles, angle BCA needs to be congruent to angle B prime, C prime, A prime. So that's right here. What about the sides, right? Corresponding sides. So AC, I'm sorry, AB, let's start with AB. AB right here, right, needs to be congruent to A prime, B prime, right? Those sides have to be congruent to one another. We also know that BC needs to be congruent to the B prime, C prime. And lastly, AC right here needs to be congruent to the other A prime, C prime. So in short, all corresponding parts are congruent. Okay. So the idea is if they tell you that two objects are congruent to one another, all their corresponding parts should be congruent as well. Okay. Just like a car, right? If you're working on a Honda Civic 2016 model and you have another Honda 2016 model over on the other side of the garage, chances are you open up the hood, you're going to see the exact same thing, exact same engine block, probably even the same cables. I mean, there's a lot of congruency there. All right, so activity 3.3, why do they coincide? So we have these two kids. They're playing with invisible triangles. All right, that means they don't see the triangles. But in this situation, for card 3, one kid tells the other that in triangle ABC and DEF, all right, so they give us a list here. Let me go ahead and start highlighting. Let's see, the kid says AB, right, segment AB is congruent to DE. Okay, so that's what they said there. AC, all right, line segment AC is congruent to DF. Okay. All right, so those two sides, right, are congruent. And then what else does he say? BC, right, is congruent to EF. Okay, so all three of the sides are congruent to one another. Okay. And then angle A is congruent to angle D. That makes sense. You can even tell like angle A is right surrounded by these two sides, right? As is angle D, even though it's just different orientation, right? And then what do we got? We got angle B is congruent to angle E. That makes sense. And then lastly, angle C is going to be congruent to angle F. That makes sense. Okay. Then let's see, this kid had to tell this other kid the steps to do before all three vertices coincide. So the vertices again are the corners or the points, right? Point A, point B, point C, D, E, and F. He says, oh, okay, so he's doing a transformation here. He says first translate triangle ABC. So I'll tell you what, let me clean up our screen here. I'm going to trace over our figure. And the reason is because we're going to do a sequence of transformations. And we're going to see if the figure maps perfectly onto DEF, right? So translate. So let's do that. So first things first, translate. So we're translating triangle ABC by the direct line from A to D. So A to D. So hopefully you're paying close attention. Translating up from where point A maps onto point D. Okay, so A maps onto D. Nice. I think that's close enough. I'm trying to be as precise as possible here. Okay, so that was the first step. So again, from A to D. All right, so we moved from A to D. And that's why A now maps on to D, right? All right, and next thing you know, he says rotate. Let's figure out what's going on there. So we're rotating the image, all right, that we just translated, using D, right, as the point of rotation, okay, so that the rays A double prime, B double prime, and DE line up. Okay, so let me label A double prime real quick. That's up here. That's up here. So these are the double primes that this kid is talking about. And we're trying to line up AB or the AB double primes, right? This segment right here. We're trying to line that segment up with DE, which is right here. Okay, so we're going to go ahead and do that. All right, so let me see. Let's copy this. I'm going to trace over again, just so you can see it. Okay, there we go. Okay, so again, we did the translation. And then there's the rotation. So A double prime, B double prime, all of a sudden rotates around D, right, to where it maps on to segment DE. And I'm trying my best here to line this up with my stubby fingers on a touchscreen. Oh, almost had it. Oh, lost it. No, almost had it. Hi, Vay. Come on. All right, good enough for government work. Oh, come on. There we go. Trying to line it up a little bit more. There's a bit of a delay on my screen here. There's like a 20-second delay. Horrifying. It looks good on my screen, but it doesn't look good right now on your screen. Hopefully that adjusts. Okay. So instead of just waiting for the image, I'll just get going, and then hopefully the image updates pretty soon. It looks like it's doing it right now. There we go. All right, and then it says reflect. All right, so we're going to reflect triangle A double prime, B double prime, C double prime, so the green triangle, okay, across DE. All right, so again, DE, let's use pink. DE is this line right here, okay. All right, so we're going to reflect across, and if we do that, your green triangle will reflect across and map perfectly onto this other triangle. Okay, now is there any questions here? Yes, there are some questions. Okay, so as you can see, this kid tells the other kid all the parts are congruent to one another, right? All the sides are congruent to one another. All the angles are congruent to one another. And then here's a sequence of transformations at work. Right, to get one triangle to map onto the other. So we know for a fact that these three triangles definitely congruent to one another. So let's go ahead and answer these questions. So in number 1, we know that rays A double prime B prime, A double prime B double prime and DE line up because we said they had to, but why do points B double prime and E have to be in the exact same place? All right, so if we look here, all right, we had to rotate to get B double prime to map onto E, right? That's what they're talking about, from here to here. Okay. Now, we already had A double prime mapping onto D after the translation, but the rotation was meant to get B double prime onto E. Okay. Now, trying to answer this question a little bit more accurately, why do they have to be in the exact same place? Well, what were we lining up for? What was the next transformation after the rotation? Right, we went from the red triangle to the green triangle for a reason, because we were setting up to do a reflection, right, across DE. So in order to get that solid reflection, we had to get B double prime to map perfectly onto E. That's why it had to be exact. Okay, so we were setting ourselves up. Okay, so to accurately reflect, right? To accurately reflect triangle A double prime, B double prime, C double prime across line DE, right? That's why we had to precisely get B double prime to E, right? And we finally reflect across DE, right? We do that for number 2. And then how do we know that the image of the ray A double prime, C double prime, and ray DF will line up? Well, let's take a look. All right, so let me label this correctly. So here's C double prime, right? A double prime is where D is, right? A already maps on to D. So if you do the line of reflection across DE, A double prime is already on top of D, right? And the distance, remember, reflections preserve distance. So the distance from A double prime to C double prime is going to be the same as D to F. Okay, so when you reflect C double prime across DE, it will map perfectly onto point F. Okay, so that's basically the result for part A, for number 2. Okay, because reflections preserve distance. And if you think about it, okay, the kid earlier tells us that AC is the same or is congruent to DF, right? So one of the kids already even mentioned that. How do we know that the image C double prime and point F will line up exactly? Again, that's more about reflections actually. So that answer should probably go here. And then the answer for A is probably better to say mentioned here earlier, right? So student mentions, right? Or student states that AC is congruent to DF, right? And then the translation, right? From AC to A prime, or A double prime to preserved distance. Okay, so you could have mentioned something like that. They even tell us that AC is congruent to DF right off the bat. Okay, so that's the end of lesson 3. If you have any questions, let me know. Other than that, have a beautiful day.